Hi everyone, joining me is the CTO and co-founder of Aqua Security. Hi Amir.
Hello, Anna.
And first of all, welcome. And can you tell us a bit about your background and how you've gotten into cybersecurity? What motivated you to start Aqua Security and how has your journey been so far?
Yeah, sure. I started my career about 25 years ago. I was working for a small Israeli startup that after some time got acquired by a very large software company. And this very large software company was actually a security company. It was the owner of security.com, a very good domain to own. Right. I was working in this software vendor for about 15 years. It's a very large software enterprise. And, working for a large company for such a long time allowed me to work on different areas. So I worked on web application firewall, on data leak prevention, on host-based security, web security, so many different domains. So it was lucky for me to work for a large organization with so many domains and capabilities. And this is where I got my background in security. And about 15 years in the same job or in the same organization, I started thinking to myself, maybe I know enough, to do something else. And I remember it was 2015. I started working with a new technology. The name of the technology was Docker containers. It was back then it was something new. And as I was playing with the technology, I actually felt in love, right? I was amazed by the fact that you can take software and it will work on your laptop, and the same software without the need to install anything will work exactly the same in the cloud, right? You didn't need to change anything. So I fell in love with it. I started using it myself. But then I identified that it was missing some of the security properties that I was aware of, right? It was missing access control, it was missing encryption, it was missing so many things. And I thought that I'm coming from a security background. I knew all about how to make software more secured. And I decided basically to leave my job and to start a company, to start Aqua, where our first goal was to make this technology, the container technology, usable for large organizations by making it much more secured.
And so you have quite an extensive experience. So what are the most significant trends you're seeing in the cybersecurity industry today? And you mentioned cloud security. So how are cloud security challenges different from traditional on-premises security challenges now?
Yeah, so what we are seeing, in the last 10 years, I would say, more and more organizations are moving their software to the cloud. So, back then, organization used to have servers inside of their own data centers, what is called on-prem. And when you had servers on-prem, everything was a bit slow. When you wanted to upgrade the software or to install a new version, you had a lot of processes. It was usually a manual process. Therefore, the software lifecycle took weeks and sometimes even months in order to do a change. As organizations, like I said, in the last 10 years, were moving to the cloud, suddenly things started to become simpler and smoother and faster. So you can set up an entire data center by just a click of a button. You can upgrade the data center by writing a piece of code, right? And everything is done very, very fast. And with the fact that things are now much more faster, then security had to keep up with the pace, right? If 10 years ago, when you wanted to secure your application, you wrote a big spec of what are the security controls that you want to deploy, and then you had another team which was responsible to take that spec and to implement the security controls. These days, what we are seeing something called DevSecOps. We are seeing developers that can write code, they can write infrastructure as code, and they can also write the security spec and automate everything together. And you get the software deployed and secured in the same moment, right? So, the trends that we are seeing, these days is companies moving to the cloud. And as a result, they need to modernize their security posture. They need to modernize their security processes. And they are looking how can they automate much more than they did in the past with regards to security. Otherwise, if they don't do that, what happens is that software is very fast. You can deploy, like I said, multiple times a day or within hours. And if you don't have security, attackers can leverage the fact that software is missing security controls, and it takes minutes for between the time you run a workload and expose it to the internet. It takes basically 8 minutes to scan the entire internet. So it takes minutes for someone now to identify that there is now a new workload. This workload is missing security controls, therefore an attacker can get inside, right? So you really need to make sure that security is as fast as you can deliver software.
Can you discuss some of the cloud and security patents that you hold? How have these innovations been implemented in Aqua solutions?
Yeah, sure. Aqua, some of the foundations of Aqua is based on patents that we created. I can mention one of them that I really like. It's a patent about virtual patching of vulnerabilities. So what is the virtual patching and what are vulnerabilities? So when you deploy software, to the cloud, it might be that on the first day that you deploy the software, there are no vulnerabilities, right? You are using latest and greatest open source packages. There are no known vulnerabilities for those packages, therefore everything is fine. But many times, after a while, it can be a day, it can be a week, vulnerabilities are being disclosed. Vendors will publish in NVD that now there is a new vulnerability for open source package. And as a result, the outcome is that you might have software running in production, and this software just became vulnerable for some misconfiguration, for some flaws in the code, or for some bad handling of inputs. So there can be different attack vectors that will leverage those. The patent that we created was how can you identify whether your software is actually exploitable, whether your software is actually running in a way that an attacker can leverage the vulnerability. So what we did in the patent is we monitor all of the activity of your software. So we see all of the files that your software is opening. We see all of the network ports that your software is listening to. And then what we do, we compare that to the information that was disclosed with the vulnerability. We can see that the vulnerability only affects specific files, or the vulnerability only affects specific ports or specific network flows. And then what we do in this patent, we compare the two. We see whether your software, your application, is actually using a file that is vulnerable, or a network path, or a port that is vulnerable. And if we see that it doesn't use anything that it's vulnerable, although the software itself is vulnerable, but it's not using any of the exploitable path, then what we do, we block those options to access files or to access network that can basically exploit the application. The result of this patent is that now organizations can run software. They can run software that is even vulnerable, and they can take the time to fix the vulnerability. Usually it will take them days to fix the vulnerability. And in the meanwhile, they can basically prevent the malicious activities from being activated, from being exploited on the software that they have running.
And so could you provide more details on the headcrab incident and how Aqua Security managed to establish a direct line of communication with the attacker, and what have been the significant learnings from X?
Sure. So as part of our cloud native research, what we do is we have honeypots that are spread across the internet. Those honeypots are running different flavors of software. We are running web applications, we are running databases, we are running infrastructure software. And what we are doing with those honeypots, they all have public IPs, so they are exposed to the internet. And we are just waiting, right? We're waiting for attackers basically to attack our infrastructure. And then what we do, we learn the attack, we learn the patterns of the attack, what do malicious actors are doing, what is the activities that they are doing as a post-exploit. And one morning we came to the office and we saw, we got a new attack it was on a Redis server. So we saw some post-exploitation activity, a lateral movement, attempt to steal data and to send that data to the internet. And so as we researched, those activities, we've identified that it came from Redis server, right? So we started reverse engineering the code. We started looking at what was the malware that was inserted into the Redis server. We've identified that this was created because of a misconfiguration. So Redis was configured in a way that was too exposed to the internet and without security controls. Later on, we found out that there are thousands of Redis servers with such configuration exposed to the internet. And the outcome of our research was that we've identified that the malware that was injected into the Redis, which we named the headcrab, actually when we disassembled it, we saw that it included a blog, right? Like an attacker writing comments about the evolution of the malware and changes that the attacker did in order to improve the malware over time. So it was like a change log of improvements to the malware. Some of the change logs that we've identified were actually related to Aqua. The attacker, specified that he was able to test the malware against some tools and improve it so that vendors like Aqua will not be able to identify it. So it was quite a funny story to see, basically to get information and messages from threat actors through a malware. So this is something that we saw in headcrab, and later on, headcrab number 2 was actually a variation of headcrab with more improvements that the attacker tried, to evade our defense, Aqua's defense. So it was also in the change log of the malware. There were additional writing from the attacker saying, "Oh, this time I will be able to evade Aqua. I did the needed changes." But still we were able to find it, waiting for headcrab number 3.
So what would be the best practices for organizations to prepare for and respond to such cybersecurity incidents? How important is real-time threat intelligence, preventing and mitigating the attacks?
So, when we work closely with organizations, usually we advise them not to start security at the incident response and post-exploitation, right? You should establish a security program that actually starts very early in the design phases. Things like threat modeling as you are writing new software. How can you do analysis of what you are writing and make sure that it doesn't have any security issues, with the architecture and the way that the software is built. The second phase is as you are writing your code, how can you ensure that you have good security hygiene, that you don't have vulnerabilities, you don't have secret in the code, right? So you can think about it as starting security in an approach where security is built into the development phases and ensuring that you're doing everything you can to release software that is where security is baked in and where it has a very good hardening and hygiene. So this is step number 1. And some of what we are doing in Aqua, we are actually helping with those processes, right? We integrate in the development lifecycle and we help developers write better code. We have some open source tools that we release to the community to help developers write better code. And we also have commercial tools to help with that. So this is like phase number 1. After you've done that, you've greatly reduced the attack surface, right? There can, attacks can still happen because of, new vulnerabilities are discovered every day. You still have blind spots, right? You're still dependent on third-party software that might have issues. So it doesn't mean that, shifting left will help with everything, but it will greatly reduce the attack surface and greatly improve your security practice. As you now deploy your software into production, what we usually advise our customers is to have some active protection and monitoring to everything that's happening in your cloud environment. So by active, I mean identifying whether there is activity that is unknown or unauthorized, ensuring that you don't have permissions, applications running with too many permissions. So basically applying a zero trust approach to both what the applications can do with regards to networking and what the applications can do with regards to their permissions. And lastly, monitoring everything that's happening in your production, analyzing that against known threat actors, but also against suspicious and malicious activities, and basically using this information in order to create incident response team that can, first of all, respond to an attack if something happens based on patterns and based on malicious activities. But second of all, if something did happen in the organization, you really need to understand the blast radius and the impact. So what we are suggesting is to keep the logs, to do full forensics of the environment, so that if something did happen and you now need to understand the impact, you have enough information to analyze it.
And what about social engineering? So what strategies have proven effective in improving cybersecurity awareness among employees, and how critical is user awareness and training in preventing cybersecurity breaches?
Yeah, so I can give you a nice angle about social engineering in the domain of cloud, because it's a bit different than social engineering in the domain of endpoint security. In the domain of endpoint security, your target is to get into the employee's laptop, right? And there can be different ways, like sending an email with phishing, or sending a software where someone will double click and run it on their laptop. So, the social engineering in those worlds requires identifying who to attack, identifying what are the items that they will click on, right? And trying to figure out those items. In the world of cloud native, your target will usually be developers, right? So as social engineering for developers, threat actors are thinking a bit differently. So I can give you one example, hijacking open source projects, right? So this is something that we had a nice blog about it a few months ago, where you have developers that are maintaining open source projects. Once those developers, after a few years, they will need help to maintain the project, because there is a lot of new releases and bugs and things to fix. And one nice attack of social engineering on open source developers was by a person that was offering help to maintain an open source project. So it starts by providing real help, fixing bugs, helping with the release cycles. And after a while, when a trust is established, then the maintainer might decide to give more permissions to this developer or to this person, and basically trust this person to take ownership on the open source project. And when this happens, the outcome can be devastating, because you have now hundreds of organizations that are using an open source package, and they are not aware that this open source package is now maintained by malicious actor. That using social engineering techniques, this malicious actor was able to gain the trust of the original maintainer, and now add some malicious code into the open source project. And now you're getting into your organization some backdoor code or malicious code, and you don't even know about it. This is something that in the industry it's called software supply chain security, and it's a very interesting domain to look at because it has a good correlation between cloud, which at the end of the day it's running the software, and the actual developers and open source, where if they are being attacked by a social engineering threat actor, then the outcome will be actually your data breach in your cloud and lateral movement in your cloud. But those attacks are actually coming from the developer side, not from the network or not from a misconfiguration.
Okay, thank you. And maybe as a last question, what advice would you give to organizations struggling to keep up with cybersecurity?
So, these days, or this year, it's the year of AI, right? So if I'm now a new organization and I start my security practices, there are a lot of tools that can actually improve your security, which are based on AI. And I'll give an example. If 2 years ago, when you had to start your security program, you had actually to build it yourself. You had to buy tools that will help you improve your security posture. You had to implement them. You had to have a security professional, right? And everything cost, it was a lot of effort, time, and resources. These days, you can actually have a shortcut for most of that. There is a lot of knowledge that can be achieved using AI, right? And I'm seeing a lot of new capabilities, new vendors that are providing more secure programming using things like a copilot or a AI that can help you not only write better code, but also make sure that this code has less security issues. I'm seeing tools that can help you do the incident response. So as you are, you're part of a security operation team, you're now, you got an incident from one of your tools. And there are nice AI capabilities that can take the information from the attack and help you at least do the level 1 investigation for that incident, and basically improving the time that you can respond to an incident, right? So if these days I'm starting my new security program, that's an advice that I give to my friends. Start by looking whether you can have quicker time to value by leveraging AI as much as possible. And then once you do that, start looking at what's missing and what tools you need to implement in your organization together with the help of AI.
Okay, great. Thank you, Amir, again so much for joining me.
Yeah, sure. Thank you, Anna.